All right, so you know how much we all love our gadgets, right? But have you ever stopped to think about what makes them actually work?
It's something most people take for granted until their device malfunctions, of course.
Exactly. And that's where today's deep dive comes in. We're talking about the unsung heroes of electronics manufacturing, test probes.
Test probes, not exactly the most glamorous tech top. It's something most people take for granted until their device malfunctions, of course. But
I know. They might seem a bit, well, niche, but trust me on this one. We've been digging into those sources you sent, and let me tell you, these little guys play a critical role in making sure your phone doesn't burst into flames and your car actually starts in the morning.
well, when you put it that.
Seriously. So to kick things off, let's define what we're dealing with here. What exactly is a test probe? Imagine you've got all this sophisticated testing equipment, but no way to connect it to the tiny circuits in your phone.
Right, it'd be like trying to listen to music with headphones that don't have a jack.
Perfect analogy. So test probes are basically those connectors. They're the bridge between the testing gear and the electronics themselves.
Exactly. They allow engineers to send signals and take precise measurements at very specific points without having to painstakingly solder and desolder connections every single time.
So it's all about precision and efficiency, especially when you're talking about the microscopic components in modern electronics.
Absolutely. And that's just one type of test probe.
Yeah.
There's actually a surprising amount of variety in the test probe world.
Oh, yeah. Tell me about it. I was going through the sources, and I swear I need a whole glossary just to understand all the different types. We're talking threaded probes, step probes, switch probes. It's like a whole secret language.
It can definitely feel that way. But don't worry, we'll decode it all for you. Each type of probe is designed for a specific purpose.
Okay, so let's break it down then. Let's start with a classic, those spring-loaded probes you always see. What makes them so popular?
Well, think of a pen clicker.
Right, okay, I'm picturing it.
That spring mechanism inside, that's what gives spring-loaded probes their consistent, reliable connection. The spring ensures that the probe tip maintains contact with the circuit, which is crucial for accurate measurements.
Makes sense. You don't want to lose connection when you're dealing with sensitive electronics.
Exactly. And not only is it about accuracy, it's about preventing damage too. A loose connection can cause arcsing or shorts, and that's the last thing you want when you're testing.
So those spring-loaded probes, they're kind of like the workhorses of the testing world. Reliable, consistent, always there for you.
That's a great way to put it. They're the go-to choice for a wide range of applications. But there are times when you need something a little more heavy duty.
Okay, now you've got me intrigued. What kind of situations call for a more, shall we say, robust approach?
Well, imagine your testing equipment in a factory setting where there's a lot of vibration and movement.
Oh, I see where you're going with this. Those delicate spring-loaded probes might not cut it in that environment.
Exactly. You need something that can withstand those harsh conditions and maintain a secure connection no matter what. And that's where threaded probes come in.
Threaded probes. They sound intense.
They are. Think of them like the heavy-duty bolts of the probe world. They're designed for applications where you absolutely cannot have any interruptions in the connection.
So we're talking industrial strength connections here. What kind of applications are we talking about specifically?
You'll find them in all sorts of places: manufacturing, automotive testing, even aerospace.
Aerospace. Wow, so these tiny probes are literally helping to keep planes in the air.
It's true.
Yeah.
And it just goes to show how critical it is to have the right probe for the job.
Okay, I'm starting to understand the importance of having a diverse toolkit when it comes to test probes. So we've got our reliable spring-loaded probes, our heavy-duty threaded probes. What other tricks do we have up our sleeve?
Well, let's talk about those pogo pins you mentioned earlier. Remember those?
Oh yeah, the ones that sound like they belong in a circus act.
Well, they are known for their springiness. Pogo pins are unique because they're designed for repeated connections, and they're incredibly durable.
Okay, so give me an example. Where would you find these pogo pins in action?
Ever notice how satisfying that click is when you connect your laptop charger?
Oh yeah, it's like a little confirmation that you've made a solid connection.
That's often pogo pins at work.
Yeah.
They're perfect for situations where you need a secure, reliable connection that can be engaged and disengaged multiple times.
So it's all about that balance between a secure connection and ease of use. Fascinating. And I can see how that would be important for something like a laptop charger that you're constantly plugging and unplugging.
Exactly. And as our devices get smaller and more complex, the demands on test probes increase as well. That brings us to our next category: Microprobes.
Microprobes, as in really, really small probes.
You got it. Think about the smartphones we carry around in our pockets. They pack an incredible amount of technology into a tiny space.
It's mind-blowing how they keep making those chips smaller and smaller.
It is. And testing those miniature components requires specialized tools, like microprobes. These probes have tips that can be thinner than a human hair, allowing engineers to make contact with those minuscule circuits with incredible precision.
Wow, thinner than a human hair. That's some seriously delicate work. I can only imagine the level of engineering that goes into designing and manufacturing something that small.
It's no easy feat, that's for sure. Miniaturization presents a whole new set of challenges, from material science to signal integrity.
So it's not just about shrinking everything down, it's about maintaining functionality and reliability at those microscopic scales.
Precisely. But that's a whole other deep dive for another time.
All right, so we've got probes for precise connections, probes for heavy-duty jobs, probes for the microscopic world. What else is there?
Well, we can't forget about the high-voltage probes. These are the daredevils of the test probe world.
High-voltage probes, as in the ones you use to test things carrying a lot of power.
You got it. We're talking about the kind of probes used to test electric vehicle batteries, industrial equipment, power grids, anything where you've got serious electrical current flowing.
Right. Those EV batteries we talked about earlier with hundreds of amps running through them, that's a whole other level of don't try this at home.
You can say that again. Safety is absolutely paramount when you're dealing with high voltage testing.
I can imagine. What makes high voltage probes different from the others? Is it just about using more insulation?
It's more than just slapping on some extra rubber, that's for sure. High voltage probes are engineered from the ground up to handle those extreme conditions. We're talking specialized materials, robust construction, and a whole lot of safety features built in.
So it's not just about preventing a bad measurement, it's about preventing a potential disaster.
Exactly. One wrong move with a high voltage probe, and you're talking about serious risks, arcsing, fires, even explosions in some cases.
Okay, that's a visual I could have done without. But I get your point. It's about respecting the power involved and using the right tools for the job. Speaking of the right tools, I kept coming across these terms in the research. Vacuum test fixtures and automatic test equipment sounds pretty high-tech.
It is. We're talking about the cutting edge of electronics testing here. Imagine a highly sophisticated assembly line where thousands of components are being tested every hour, all with incredible precision.
It's like a scene out of a sci-fi movie. Robots doing all the work, testing things at lightning speed.
That's not too far off. Automatic test equipment, or 8EE, is becoming increasingly common in electronics manufacturing, and test probes are a key part of that.
So instead of a human hand carefully placing a probe, it's a robot doing the poking and prodding.
Precisely. 8E systems use robotic arms equipped with specialized test probes to make rapid, repeatable connections with the components being tested. It's all about speed and accuracy.
It's amazing how automated the process has become. But what about those vacuum test fixtures you mentioned? What's so special about testing in a vacuum?
Well, not everything we test is designed to operate in the same environment as us. Sometimes you need to simulate extreme conditions, like the vacuum of space, for example.
Ah, that makes sense. Not all electronics are going to be used here on Earth.
Exactly. Vacuum test fixtures allow engineers to test components in those extreme environments, making sure they'll function flawlessly, whether they're in a satellite orbiting Earth or a rover exploring Mars.
Wow, that's incredible. It really highlights the range of applications for test probes.
Yeah.
We've gone from testing tiny components in a smartphone to testing equipment that's going to be used in outer space.
It's testament to the ingenuity of the engineers and the versatility of these often overlooked tools.
You know, reading about all these different types of probes and their applications really highlights the importance of having the right tool for the job.
Absolutely. And it's not just about the probe itself, but also about the expertise of the engineers who design and use them. They're the ones who understand the nuances of each probe type and how to get the most accurate and reliable results.
It's a good reminder that even in our increasingly automated world, human expertise is still essential.
Couldn't agree more.
Okay, we've covered a lot of ground here, from the mechanics of spring-loaded probes to the high-stakes world of high-voltage testing. What are some of the key takeaways you hope our listeners walking away with today?
I think the biggest takeaway is just how essential these often overlooked components are to our modern world.
Yeah.
Every time you pick up your phone, drive your car, or even just turn on a light switch, you're benefiting from the work that test probes have done behind the scenes.
It's a good reminder that innovation isn't always about flashy new features. Sometimes it's about perfecting the fundamental building blocks that make everything else possible. But before we get too philosophical, let's switch gears for a moment and talk about something I found particularly interesting in the research: the environmental impact of electronics manufacturing. There was mention of something called e-waste and how it relates to test probes. E-waste, yeah, that's a big one. It's kind of like the elephant in the room when we're talking about all these amazing gadgets, isn't it?
It's definitely a growing concern. We're churning out electronic devices at an unprecedented rate, and those devices have a limited lifespan. So what happens to them when they reach the end of the line?
That's the million-dollar question, right? Because nobody wants to think about their old phone ending up in a landfill somewhere.
Exactly. And that's where the term e-waste comes in. It refers to all those discarded electronic devices, phones, computers, TVs, you name it. And the problem is that a lot of this e-waste ends up being improperly disposed of.
And I'm guessing that's where the environmental concerns come in. Because these devices aren't exactly biodegradable, are they?
Not at all. Electronic devices contain all sorts of hazardous materials, heavy metals, flame retardants, toxic chemicals, and when those materials end up in landfills, they can leach into the soil and groundwater, causing all sorts of environmental problems.
Okay, so we've established that e-waste is a bad thing. But where do test probes fit into all of this? I mean, they're tiny compared to a whole computer or a TV.
It's true. They might be small, but their impact is significant. Remember how we talked about how test probes help ensure the quality and longevity of electronics?
Yeah, by catching defects early in the manufacturing process.
Exactly. And that's key because when a faulty device makes it out into the world, it's more likely to fail prematurely, leading to, you guessed it, more e-waste.
Ah, I see the connection now. So, by helping to prevent faulty devices from ever reaching consumers, test probes are actually playing a role in reducing e-waste.
Precisely. It's all about extending the lifespan of our electronics. The longer a device lasts, the less likely it is to end up as e-waste.
That's a really interesting perspective. It's like those test probes are little environmental heroes working behind the scenes to make our tech habits a little more sustainable.
I like that. Little environmental heroes. And it highlights how interconnected everything is. We often don't think about the environmental impact of our electronics, but it's a real issue.
Definitely. It's easy to get caught up in the excitement of the latest and greatest gadgets, but we need to be more mindful of the bigger picture.
I couldn't agree more. We have a responsibility to dispose of our old electronics properly, and manufacturers have a responsibility to design devices that are more durable and easier to repair and recycle.
Absolutely. It's a shared responsibility. Well, on that note, I think it's time to wrap up this deep dive. We've covered a lot of ground here, from the intricate mechanics of different probe types to the global challenge of e-waste.
It's been quite a journey. Who knew that something as seemingly simple as a test probe could be so complex and impactful?
Right. It just goes to show that sometimes the most important things are the ones we rarely even think about. To our listeners, we hope this deep dive has given you a newfound appreciation for the unsung heroes of the electronics world, those tiny but mighty test probes.
And next time you pick up your phone or plug in your laptop, take a moment to appreciate the intricate testing process that helped make that moment possible.
And remember, even the smallest components can have a massive impact, both on our technology and our planet. Until next time, keep exploring, keep asking questions, and keep those gadgets running smoothly.